I'm going to create an example that it will give you an idea what is happening on exception handling. Remember in one of the chapters in CS1, when we ask you to write import IO exception, and for that, when we read from a file, we need to import java.util.scanner. And we're going to create a scanner object in order to read a file that you put here. So you basically create a new file, and then we call the name of the file. And here I'm going to put this .txt. Obviously, I don't have that file. So I want you to remember this behavior that we have been discussing for probably 1 year. Every time you want to read from a file, your instructor told you to please import or handle this exception, IO exception, after the main. And you will say, what exactly that means? And probably they tell you, don't worry about that. We'll explain later on. Well, today is the later on. So at this point, in order to read this file, the ASD, whatever I put here, you need to put this line of code. If I don't do this, if I compile, Java will complain by telling you, you know what, this part has an unreported exception, file not found, and must be caught or declared as the thrown. You can fix the situation by putting that line of code I told you previously. And what I'm doing at this point, if I decide to save this thing, and then I'm going to compile it again, and now Java is fine with that. Obviously, if I run this exception example 1, this is going to crash because I don't have any file in my desktop. You can see right here, I don't have any file to read. So that's why we crashed this program. I'm going to show you how to handle that situation in case the file was not found without putting this throw IO exception. So in case you didn't know, we're going to use something called the try, and we're going to catch something. Now, imagine that the try is like a sandbox that you are interested in the playground, right? There's some action that you would like to perform. Here is when you're trying to read a file that may or may not be there in the desktop, or it can be somewhere else in your working directory. But here we're gonna try a potential exception. What is the potential exception? And we already have it here, file not found exception. So this is the potential exception that might be occur only if this guy is not there. So here what we're gonna do in this catch is like, in case something goes wrong, don't worry, I will catch it as a file not found exception. I'm gonna call it E, and then I'm gonna report it in here. I'm gonna put something more nicely, file not found. Can you please provide file location? Some message that provides the user enough feedback to tell it that there was something wrong when you process the file. So I'm gonna compile, and then finally I'm gonna run it. So obviously it tried to read the file again, but it was not found. So it's like, you know what, file not found. Can you please provide a file location? You didn't crash it. At least you know how to handle it. Notice that I didn't incorporate any throws IO exception in the main. So this is the whole key about this chapter, is that we're gonna show you how to handle these situations more properly and more professionally, because sometimes we want to just let it crash, as I mentioned, but sometimes we want to handle it properly. So pay attention on that. I'm going to give you another example about how this might occur differently. I'm going to call this exception example 2. And I'm not going to read from a file this time. I'm going to request the user some information. And this is probably where the most of the errors of an exception occurs, because we're not going to read from a file. We're just going to say system.in, and we're going to ask the user enter a number. So we have X, which is input dot next int. I'm gonna basically request this information twice, one for X, one for Y. And what I'm going to do, I'm gonna create Z, which is basically X divided by Y. And then we report the division is, I put here Z. I'm gonna clear my screen. I'm gonna compile this example 2. And then I'm going to run this program. So enter a number 10 divided by 5. I'm expecting 2. Now that is assuming that the user gives you the correct value. Enter a value 10, and then it will give you 0. What is 10 divided by 0? It's not 0, by the way. it will throw an exception called arithmetic exception. You cannot divide by 0. So here you crash your program by trying to divide by 0. So that is something that occur only because you didn't pay attention on how to handle the situation. It's just a basic division, professor. What harm can this be? And at this point, it make a big harm. It crashes your computer. So the next step is to identify which of the following lines is there responsible to performing a potential exception. And this comes in the fact that we're trying to divide. This is line 11. So when you identify the potential bug that you will have, you can just put, hey, you know what? I'm going to try the following. This might occur here. I'm going to try this part. And the worst case scenario is in case y will throw you something called arithmetic exception. So I'm going to copy this part here, and then I'm going to say, I'm going to get an arithmetic exception possible. I'm going to call it E because it's an object, and I'm going to do system out print line E. If I do this, let me just clear my screen and I try to compile, Java will recognize that it doesn't know what Z is. So now you need to be careful how you basically, this is a syntax error. This is not an exception. How Z is being declared, because be careful with the scope that you declare. Z lives only inside of the scope of the try. So at the time of line 17 is trying to do something like access them, it will not be recognizable. So in order to fix this problem or this exception, there's a couple of ways to do, but the easiest thing to do is basically declare or define the variable Z outside of the scope. So when I try to compile this again, this time it will not recognize a problem because Z is now outside of the scope. So when I try to run this program, Java exception example 2, 10 divided by 5, no problem, 2. 10 divided by 2, and then you have this. 10 divided by 0. Now you have Java lang arithmetic exception divided by 0. So here we're still providing the actual arithmetic exception that we inherited divided by 0. So you're welcome to use this at this point, but you handle it, the situation. Or you can do something else. You can actually basically constrain and let the user know, sir, ma'am, you can't divide by 0. Maybe some drama, doesn't hurt. So what I'm doing here, I'm gonna compile and I'm gonna attempt to run the same program again. And 10 divided by 0, instead of just having the arithmetic exception, you have a customized and more personable exception message. Yeah, you cannot divide by 0. Here I'm reporting division is Z because that's basically outside of the catch. After we break or after we crash the code, that's the way you represent it. Ideally, you have to use something called finally that basically will handle situations in case they were successfully made. You handle it by the finally. Let me try this again. This is the ideal one. 10 divided by 0, you have, sir, ma'am, you cannot divide, the division is 0, because finally it gives you a space when you can perform certain actions in case they didn't go through. So we have try, we have catch, and finally. Now, okay, good. Now, what happened if Granny is playing with your code and you say 10 divided by cow? So here we're handling one specific exception, which is the arithmetic exception, but in reality, cow is not a number, okay? And that's not even an arithmetic exception. Something happened is here, something wrong. It's called input mismatch exception. So here we're trying to do something that it was even worse of the just arithmetic exception. This is something that it gives us a different perspective of a different level of exceptions. In this case, that, hey, you know what, they don't match. But who is responsible? Is the division responsible? False. It's not responsible. It's responsible the value that we provide at y. Yeah, but it can be at y or it can be at x. So both of them, they're expecting integers, and we give cow, and that's not cool. So what you can do you can extend the try maybe a little bit higher to include the values that you get from the user, both of them, and also the division that you internally you're gonna perform. Now, if I do this, this is gonna be outside of the scope of the entire operations. So what I'm gonna do, I'm gonna go outside of my try and declare it more globally. I hate to use that word globally, but at least it's more visible for all these aspects. So I already saved it this time. I'm gonna compile it again and I'm gonna run it. So, and of course, I'm gonna put here cal, boom. Yeah, still an exception. Why? Well, professor, you tried this. This is a nice sandbox you have there, but you only handled the arithmetic exception. But what happened to the other one? Ah, that's a different situation. The input mismatch exception was provoked by providing a string instead of an int. So how can I handle it? Well, the same way you handle the arithmetic exception. So for one try, you can have multiple catches. Like for example, an arithmetic exception in case you want to divide, or it can be another catch that will give you the input mismatch exception. I'm gonna call this one E2. I'm gonna call this E1, exception number 1, exception number 2. And then you can say something more system.out. Actually, the correct one is system.error. We can actually exercise this part in case you want to do a standard error. This is a convenient way to justify there was an exception handling. And I don't know, you can tell Granny here something like, Granny, do you think this is a joke? Only numbers, please. Oh, you know what? Input mismatch exception belongs to java.util, but I'm only importing scanner. So I have to use the wildcard at the very top to include everything. I mean, I guess I can do this also. I can import scanner and I can also import input mismatch exception. I can do that thing and that will work, but we can use the wildcard. You see, that works. But we can also use the wildcard to specify, hey, give me everything that is in java.util, including the exception, including scanner. And if I'm gonna clear this real quick. And if I compile this part, it will just cover everything inside of this. So enter number 10 and then divide it by cal. Granny, do you think this is a joke? Only numbers, please. So you can do that thing. Or maybe enter a number, cal. Granny, do you think it's a joke? Only numbers, please. So that way you kind of restrict Granny to give us evil input. And don't worry, the sandbox will take care of it at this particular scenario. We have multiple catches and the final just in case you want to close something else.